Hi guys, I welcome you to my channel. Today I will solving this lead code problem, and where it is marked as hard, and it is hard if you are trying to solve using heap. This is question basically asking that if you are trying to solve the problem into O of log n into n time, O of log n into k time, probably it will be hard only. If you are trying to solve into O of n log n, it will be small. So I'll first solve into of log n log n, then I'll try to optimize it using heap and all. So let's see that. And it took time for me to understand this problem, that's why I'm making this video very late. Okay, so let's start the problem. If what saying that a median, what is the median? Median is the middle value of ordered, here it was ordered, right? So that's what I forget that median, we should find median in a sorted array. So when I'm saying that median is the middle value in the ordered integer list, it means that median, the if you're going to find the median, you must have a list that is sorted, right? So if you the list is unsorted or not sorted, and if you're trying to send middle of that list, you get the wrong answer. So for the median, you have to have a list sorted. Got it? Right. So let's find it. So you will have a stream of numbers, and whenever someone has to add number, let me create a list. This dot list, it will be an array. Whenever someone asks to add list, so this dot, so not this, sorry, self dot li dot append this num, that is the, yes, that's it in the append. So it will take one to append it. Now we have to find median. So to find the median, we have to find the we have to sort first. So if they know, we will find length first. So length of list will be the length of list will be length of self dot li. If they know length, if they return in g, if length of list is 0, I will return null or return 0. Otherwise, what I'm going to do, I'm trying to find, I'll sort the array first. So how to sort in the Python? Uh, how to sort uh, how to sort this dot li dot sort, probably we have sorted this array. Now we have to just return this. If length of li is modulus 2 is modulus 2 is 0, if this is the case, I will return the I'll return what I'll return the mid. I'll find mid first. Mid will be the length by 2. So return the this dot li of length of li by 2 minus 1. Let me find index first. Index list index will be the list of li of 2 and minus 1, and so index minus 1 and plus this dot li index plus index, that's it, index. And I will find the median, so I will do float of this two, I will sum first, then I will return float of this two. If modulo is 0, if not, else I'll just return this dot li of index, and that's it. So we have to sort first. Let me check. So here in the finding median, it will take O of n log n, because we are sorting them, and this is a sort method of Python. I don't know. Let's check it. Hmm. What is wrong here? What is wrong here? This dot li of index, right? Invalid syntax. What is syntax is invalid? Sorry, self dot. It will be self dot, not this. So I am referring Python here. That's why it's giving you this salvage. Yeah, it is self of li. What is happening here? Print index. String index here. Invalid syntax. Self of li of index. Self of li of index. I am not able to understand what is the problem here. What is the index here? So index is the index. I don't know. Invalid syntax. What is wrong here? Invalid syntax. We have length of li, length self dot length, length of the list. If length of list is 0, I'll return 0. Otherwise, I'll sort it. I'll find the index. If index modulo 2 is 0, I will return that. I will return the modulo of 2. I will return first. I'll add the median and middle plus 1. Sorry, median minus 1, and I will sum them. Right? Sum them. Uh, mm, if length is 4, means 2 and 3, not 2 and 1. So it will be 2 plus 1. Yes. So I will return self dot li. What is the problem here? Index is not defined or li is not defined. Self of li is defined. Self of list is defined. Index is not defined or what? Index is also defined. So let me check. Invalid syntax. Where I'm doing wrong here? Oh, sorry. Extremely sorry. This colon I should not define there. Index is out of bound. List index is out of bound. If I have 4, 1, 2, 3 and 4 we have, right? And mid is what? 2. Would where 2 is 2, this one. This one, so minus 1 and plus 1, yeah. So minus of the index and current index. So if I submit this code, this will work. Basically, and see how we sort this element. List dot sort. That is working, but it is not optimized one. So how can we optimize it? I have to update this add now, and we have to use a min heap. You have to use a heap concept here to optimize this problem. So how can, and this is the min heap problem as well. So what is heap? So here you see here what is heap. We have already. Heap is a completely binary tree data structure that satisfy the heap property. For every node, the value of its children is greater than or equal to its own value, and heap are usually used to implement priority queue, where the smallest one element is always at the root of the tree. It's not giving good explanation. Let me ask. A heap is a useful data structure where it is necessary to repeatedly remove list with highest or lowest priority, when insertion need to be inserted with the removal of the root node. Nothing is here. No in good. Nothing is good. Example. So what is heap here? Basically, heap is a data structure or a complete binary tree. So complete binary tree means if we will have you will have left. मतलब or complete binary tree means a child. If there is a root and there is a one child, if that root have left, you must have right of it. Otherwise, it is not a complete binary tree. If nothing is there, left is not defined, so we should not have right. If right is not defined, we should not have left. If right is defined, we should have left. So a heap is a completely binary tree that satisfies heap property. What is heap property? Heap property means root is always, if it is mean heap, if it is mean heap, so root value will be the smallest one from the left and from right. And if it's the max and left of the heap root, left of the root will be the smallest than right of the root, right? So he see here, this is a max heap always get greater than its child nodes. The key of the root node is the largest among the all other node. The property is also called max heap property. Nine will be the always greater than child node. 9 will be the always greater than child node. 5 will be the always greater than its children, its descendant. Maxi, but this is not complete, right? 4 right of the 4 is not defined. So what is complete? I am confused here. Let me ask ChatGPT. This is a complete. It is a maxi. Is this a max heap? Is this a max heap or what? Yes, but this is not complete binary tree. This is not complete, but this is not complete binary tree. What is complete binary tree? Let's break down definition of complete binary tree. The all levels are completely filled except possibly the last. The last level is filled from the left to right. No gaps are allowed between nodes of the last. Missing node on the left. 5. So if there is no left, so see here, all nodes have a binary, all nodes have its child, but while inserting we have to make sure that while inserting the right we have to make sure that left are completely filled. So we have these value and we have to insert. So 1 5 3 9 5, like this we have inserting this 3, and then we are going to 4 and 2, right? So if you remove 3 and bring here after 4, it will be not a binary tree, a heap or complete binary tree, because we had a chance to fill the 5 or fill the right of the 5, but we didn't fill that. We went to the 4, right of the 4, and that's why, or left of the 4, that's why it is not max. So it is a complete binary tree. This is a complete binary tree. So a heap, what is heap? Heap is basically a complete binary tree, and we have a complete binary tree that satisfy heap property. So what is heap property? Heap property is the root of the root of the any. If we have max heap property, we have mean heap property. The max heap property is basically root of the heap is smaller than its left and its right, or its children, I would say. Heap of any like root of any property, root of any heap is always smaller than root of any heap is any max heap. Root of any max heap is it's always smaller than its root dot left and root dot right. So 9 is just if this is max heap, then root of the 9 is greater than 5, and root of the 9 root value of 9 is greater than 4. This is max heap, right? I'm confused. I'm just trying to explain my point here. What is heap, what is max heap, what is mean heap. So what is max heap? Max heap, we tell when root value is greater than left of the root value, and also greater than right of the root value. So 9 is greater, as you can see in this example, 9 is greater than 5, 9 is greater than 4. You see here 5 is greater than 1, 5 is greater than 3. 4, you see here 4 is greater than 2, and there is nothing on the right, so 4 is greater than null as well. This example of mean heap. Mean element should be smaller than left of the mean element and right of the mean element. So 2 is smaller than 1 and 3 is smaller than 1. 4 is smaller than 2, 5 is smaller than 2. I'm very sorry. What is mean heap? Mean heap basically a heap where root element is smaller than the right element and left element. It's left element. So 1 is smaller than 3, 1 is smaller than 2, 2 is smaller than 4, 2 is smaller than 5, 3 is smaller than 9. So this is not binary search tree, but this is heap. Why? Because root value is always smaller than the always smaller than its neighbor or its left and right. So heap property is this key. Heap can process element. Heapify the process of creating heap data structure from binary tree. Let's put it. Nothing is there. So you got some idea, right? What is heap? What is heap here, right? What is heap? Heap is a data structure where we use a linked list or binary tree to implement heap, and where left value of heap, if that is, and we have two property of heap: max heap property and min heap property. If we are looking at max heap, then, and if you are using binary tree to represent it, root value should be always greater than the left value and right value. Root value should be always smaller, or all the left descendant of root should be smaller than the root value. All the right descendant of root should be smaller than right value. This is the max heap. And what is mean heap? So root value should be the root value. All the left descendant of root should be larger than the mean value, root value, and all the right descendant of root should be larger than the root value. This is the mean heap and max heap. So here in this problem, to find the median, we will implement a mean heap and max heap. Why? Because see, what, and you know that we can fetch mean element, max element from the heap in O of one time. So that is the reason we are using it. So we will create two heap we will create. First one is the small and second is large. So small will take the value in negative form of the number. Like if you want to insert 4, we will do like -4, -3, -2. Why we have done, I will tell you'll understand just now. And large, and large will tell you mean heap. Large will give you mean heap and small will give you max heap. So here how mean heap works: if you want to store 5, 6, 7, so small is max heap. So if you want to get the smallest value, we'll take -4 will be returned 5, right? So -4 will be multiplied by -1, that is 4. 4 is the max value in the small and last, and in large the smallest value is the 5. So if you want to find median and the length is 6, what do? You take smallest from the left, sorry, you take largest from the left and smallest from the right. So what is largest here? -4 is largest, basically 4 is largest. So how, if you are using mean heap here also, so the answer would be something like this. Mean heap here using 2 3 4, and the largest will be the, what is the, so in the smallest, what is the mean value? 2 will be returned, but I wanted 4 to be returned, right? I want largest from the smallest and smallest from the largest. That's why we have to have max heap for the smallest and mean heap for the largest. That was the point I was not able to understand, so that's I'm trying to explain you. So we will create first two heap for self dot left and self dot right. So self dot left and self dot right will be two list or heap. Now here is the main catch in when we are going to insert the element. So while you are going to insert the element, you have to check that if self dot large exists, and self dot large of 0 is greater than num or smaller than num. Yeah, not or it should be smaller than num. What does it mean? That it means that key it means that the value we are trying to insert should be in the right or large array, because the num which is 6 is greater than 5. Trying to insert 6 which is greater than 5, it should go in the large. Why? Because 5 is greater than the smallest, all the smallest value we have inserted till now, so it should go in the large. So it means that we are inserting 6 into the large, so we will insert 6 here. We have inserted 6 here. So what we'll do here, we will do self dot large dot append, and we'll do num, right? We are appending, no, sorry, this is the wrong way to append the list. We have to use that heap q dot heap push. We are inserting into large, right? So this dot not self dot large comma, what we are going to insert? Value num. If this is not case, we will do else part, like if the largest value that we are going to insert is smaller than the minimum value of large, means we have to go to the smallest. So we will go to smallest and heap push dot self dot small, and we will do negative of that. Why? And when we do negative, the largest value will go inside the small, and it will store like this. If trying to insert -5, so -5 will insert it like this, -5. So when we trying to get, it will help when you try to get the value, right? That's what we are doing here. We are negating that value so that we get the max out of the smallest. Okay, now what is next thing we have to do? Next thing we have to do is basically check if size of both the heaps is equal, or if equal or greater than, or equal or slightly or more than, or you have to check that if size of both heap is equal, also or one more than either left or right, either small or large, small or large. So what we are doing here, we are checking here that if both are equal. So why we have to do that? We have to do to get the data or to get the element correctly. That is the main part here. so that we, whenever we are trying to fetch, whenever we are trying to find the median, whenever we are trying to find the median, we get the right value. That's why we are trying to do here. We are trying to get the, we are trying to balance the tree, balance the both the heap, small and large. As we are balancing such that the one should never bigger than, like less, if small is bigger than large, so we have to make sure that large is just, small is just bigger than 1. If large is greater than small, here I'm saying the length of the large is greater than the length of small, it means that large is just greater than 1, not more than 1, right? So here how will I write? If both sides, we have to check if both, if are equal in size, equal in length, or one is, one is just one more than other, or more than other, right? One is just more than other, that means you understand what I'm trying to say. So I'll check here ki if self dot large, length of self dot large, right? If length of self dot large is greater than length of self dot small plus 1, if that is the case, like it should not have more than 1, so what we'll do here, I will pop from the large and push into the small. So what I'll do here, uh, heap q dot heap push, what are we going to push, we are going to push into the self dot small, right? Self dot small, I'll pop from the self dot large, right? And while popping it, we have to negate it to get the max heap, right? So negate of, let me pop it, how, heap dot heap q dot heap pop, and what we are going to is self dot large, yeah, we are going to self dot large, we are going to pop from self dot large, and we are popping, we are pushing it by negating it, right? Same we'll do with the otherwise. So if length of self dot small is greater than length of self dot large plus 1, I will pop heap, I will push into the smallest one, I will push into the large one, not smallest one. Heap q dot heap push self dot small, so self dot large, self dot large, and we have to pop from the smallest one, right? So while popping it, we have to make it actual string. So if that is positive, we have to multiply by negative, and negative minus negative, that is positive. So minus of heap q dot heap pop self dot small, that's it. We are done it, we are done doing it, and this is the code for add number. Now we are going to do the find median. So if I'll try to find the length of list, no, I'm trying to find the median. So if not self dot left, self dot small, and not self dot small large, if both not defined, I will return 0. Otherwise, what I'll check here, length of both of, so length of small is equal to length of self dot small, and length of large is equal to length of self dot large. If length of small is greater than length of large, if length of small is greater than length of large, then means we will return the value from the length of small. So return small dot left, so not small dot, self dot small of what, 0 basically give smallest value, and I will negate it. so I will negate it with minus, right? If some same will be the case for positive. If length of large is greater than length of small, I will return self of large of 0. Yeah, if both the case is not find, if both are not smallest, I will return the median of both. So what I'll do here, I'll do I will do what I'll do this, self dot small of 0 plus self dot large of 0 by 2. So I have to negate it minus, that is the that's it. So let me verify one more time. We are getting two heap, left and right, left not, small and large. Okay. Now in the case of sum, we will check first that if large is defined and large dot value, large dot in large and minimum value of large is greater than num, it's smaller than num, it means that all the value which we are going to insert should be inside the large. So we are pushing here heap dot large push num using this method, heap q dot heap push. Otherwise we are pushing it to small. Now this we have to check if size of both are equal. If not equal, if size of both are equal, or one is just one more than other, one means one heap is just one more than other heap, then we will not do anything, otherwise we will do. So if length of large is greater than length of a small plus 1, so what we will do, we will push into the small, we will pop from the large and will negate it to get max heap. Same will with the small, if small is greater than large, we will pop from the small and negate it, so get the actual value and some push into the heap. Now in the finding the medium, we are checking that if both are defined. If not defined, I will return 0. Otherwise we are finding the length of both. If length of small greater than length of large, I will negate it. I will negate the small value, small, like I'll negate the small value from the small, and that will return me that will tell me the bigger one. The self dot small minus, that will give me bigger, right? Same here, self dot large will give smaller one, self dot large will give a smaller one. That's what we wanted, right? Yeah, wanted that one only. And self dot small of 0, if both are not case, like we are giving even number, so we are getting the bigger one from the left and smallest one from the right, and we are doing modulo, or I would say we are not finding, we are basically finding the float value, or we are dividing it, not moduling. We are not doing modulo. Okay, so I'll test it. Let's see what is the problem here. Yeah, it got accepted. I'll submit it. See here, last time when I have submitted, this was somewhere here, and currently it is just like 1 2 3 4 5 6 5 number from the left. So my solution have been improved drastically, and it is beating 76% of Python developer, and it is taking 126 millisecond. So yeah, that's it. Very interesting question it was. So we'll meet tomorrow. Heap and priority question was done. We'll do backtracking. So after doing this, we have nearly half question we have left. We will do quickly, because we do not have 75 days to complete this problem. We'll do 2 problem a day and to complete the rest. Okay, we'll meet tomorrow, and thanks for watching. And I'll be doing again, I'll saying again, I'll do this question again and again until I get job into big tech company. So thanks for watching, and you do the same thing with me, and support me if like help, or guide me if I'm done anything wrong, and guide me if I have to do anything differently, right? Thanks for watching. Bye bye.